right, hello, Algebra 1, Lesson 51. We got my family members here. Go ahead and show them, Joe. We got Bo here, we got Chloe, and we got Mrs. Zimmerman in the back. Yes, we're all here to teach you Algebra 1. All right, so what we're going to do is we are simplifying rational expressions with like denominators. We're looking at example number 1, which says to identify any excluded values. Now we went over this. Excluded values are values that will make the denominator equal 0. So we look at this, 5 times what equals 0? Well, 5 times 0 is equal to 0, so m cannot equal 0, right? We call that the excluded value, because if you put 0 in for m, it will make it undefined. And so that's our excluded value. All right, we're going to go on. You got that on there, Joe?
Mm-hmm.
All right, letter B. All right, we have 5m divided by m plus 1. So we're doing the same thing with B. We're trying to find the excluded value. So we look in the denominator. What value for m would make this equal to 0? Well, we could solve this equation, move it over, or we could just look at it. The opposite number added to 1 would make this 0, so m cannot equal negative 1. All right? Okay, on to example number 2. All right, now this one says to simplify the rational expression. Okay, simplify each rational expression. If possible, identify any excluded values. So we want to identify the excluded values first, and then we want to simplify. Now, when we simplify, we're going to cancel any common factors in the numerator and denominator. So look here again. What can h not equal? Well, h cannot equal 0. Now we look at this. Do we have common factors? Can we simplify this? Yes, we can. All right, 8 and 12, both are divisible by 4. So 4 will go into 8 2 times, 4 will go into 12 3 times. We've got 2 factors of h in the numerator. So if we write that, it would be like h times h, and we have 1 in the denominator. So the factor, or the number being multiplied, would cancel, and so this simplified would then be 2h divided by 3. All right, let's look at letter B. All right, so that's what we want to do in all of these. When we're simplifying, we want to look, first of all, at the excluded value, and then we want to simplify. All right, letter B. Excluded value, what will make this 0? Well, 3 will make this 0, so m cannot equal 3. It can equal anything else, but it cannot equal 3. All right, then the next thing we want to do is factor, like we've done before. That's factor, take the greatest common factor out of the numerator, which would be 2. Joe, you got that video on that? All right, you've got 2. Factor out of 2, then inside the parentheses, we would have left m minus 3. All right, and we have m minus 3 in the denominator as well. So remember, when these are exactly the same, okay, if the addition and subtraction sign were different, we couldn't cancel. But since they're exactly the same, those factors would cancel out, and this would just simplify to be 2. All right, let's go on to letter C. Erase example number 1 here. Okay, letter C in example number 2. All right, we have 4y squared plus 8y over y plus 2. We look at the numerator. Okay, first of all, almost forgot. We want to make sure that we identify the excluded value. What plus 2 would give me 0? Well, negative 2. So y cannot equal negative 2. We look in the numerator. What's the greatest common factor? Well, both have a common factor of 4 and y. So we take that out and factor it. Remember, factoring is going backwards from the distribution property. All right, we look there again. Okay, we've got a common factor of y plus 2. All right, if we knew what y was, these are the same numbers. So those can be canceled out, and this would simplify to 4y. All right, and that's the end of example number 2. All right, example number 3, simplifying expressions with integer exponents. All right, letter A. Now, these expressions, since they're fractions, the only difference is they have variables in the numerator and denominator. Maybe you guys could help me with this. What do you have to add fractions? You have to have a common
Denominator.
Common denominator, good. All right, and so do we have a common denominator here? Is it the same, although it's letters? Yes, it is. It's a cubed in both. So even though it's letters, we've got a common denominator, and so we're going to use the fraction rules. All right, we're going to subtract the numerator, and we're going to keep the denominator the same, right? Just like if you had 2/3 minus 1/3, well, you subtract 2 minus 1, which is 1, and divide by 3. Same thing here. So we have b minus 2b in the numerator over a cubed. All right, now can I subtract b minus 2b? Can I do that? Yes, they're like terms. So we subtract 1b minus 2b would be negative 1b, or just negative b over a cubed. All right, thanks for your help, Chloe. All right, letter B. Let me erase here. All right, we have p cubed to the negative 2 minus 7 over p to the negative 1 q squared. All right, now what we're going to do is, like we've done before, is we're going to make sure that we have all positive exponents. So since it's q to the negative 2, remember I make the exponent positive by moving it down or moving it up. So the q to the negative 2 would be the same as q to the positive 2 in the denominator. We're going to do the same thing here. We've got p to the negative 1. I'm going to move that up to the numerator. All right, we see as we did this, just like the previous example, now we have the same denominator, both q squared. So when we subtract this, we're going to get q squared in the denominator. We have p minus 7p, which would be negative, well, we can go ahead and subtract 1p minus 7p would be negative 6p. All right, one final example. This is our application problem. Okay, it says a rectangular field has a length of 6a divided by 3a plus 4 and a width of 8 over 3a plus 4. Find the amount of fencing needed and enclose all 4 sides. So if we have all 4 sides, if we added, and there's different ways to do this, but if we added 8 over 3a plus 4 plus 6a over 3a plus 4, we would have half of the perimeter, because that's the length and width. But we know that perimeter is twice as big as the length and width, adding them up. So we're going to set it up this way to show how this. Now, common denominator, so we can add these. So we've got 6 in the numerator, 6 plus 6a divided by 3a plus 4. All right, if we add those up, actually, shouldn't have done that. Let me go backwards here. Actually, the best thing to do here would be to use the distribution property. Okay, so we're going to use the distribution property here. I'm wrong. Okay, go back on here. They don't use the distribution property. All right, I lied. Okay, we're going to add those up first since we can. Combine them. Okay, and then we have 2 out in front, which is the same as 2 over 1. Now we look in the numerator, or we look here, do we have a common factor? Well, yes, we do. We've got a common factor of 2 in the numerator. And we've got this 2 outside, 2 over 1. Well, 3a plus 4s are going to cancel out. You've got 2 times 2, which is 4. We multiply that out, and we've simplified the problem to be 4. All right, and that's it. Go ahead and stop, Joe.